So in this next part, we're going to be creating a basic player game object with the ability to move left and right. So we'll need a sprite renderer to show our player on the screen, a Rigidbody 2D, which is the physics component for a character like a player, and will help us to handle movement and physics. And then to get the input from the player, we're going to have a player input component. That's something we get out of the input system, which we installed earlier. And we're going to be creating a player controller script to actually cause the movement to happen based on the input we get from the player input component. And I'll also put here that we're going to talk a little bit about prefabs, since we might want to create a copy of our player in other levels or scenes of the game. So prefabs are super helpful for doing that. Okay, so in our gameplay scene, right click and create a new empty game object. I will just call this player for now. So we're going to need a sprite renderer component to show our player. So sprite render. Now we need a sprite, which we will get from the art assets folder. And we want to use the RV Raws Adventurer. So let's go dig into individual sprites. And we'll look for the idle sprites. Now, when you see the preview images like this, it's visual, but it's a little hard to find what we're looking for. So I'm going to take this little slider bar in the bottom right of the project window and move this all the way over to the left. So now we can see things in a very clear alphabetical order. So just go down until you get to Adventurer Idle, right past Adventurer Hurt, and we'll take the 00 frame and assign that to our player sprite renderer. So of course you could drag that into the sprite renderer sprite slot directly. Another way is that you can also drag the 00 frame onto the game object that has a sprite renderer inside of the hierarchy. So click on the player game object and then drag Adventurer Idle 00 into the sprite slot, and we'll see our character on the screen. So next we need to add another component, which is Rigidbody 2D. Rigidbody without the 2D is for a 3D game, but obviously we're making a 2D game, so that's why we use 2D. So we're going to leave the body type in dynamic, for this course, which allows gravity to automatically apply on our game object. Now, there are several ways of interacting with a dynamic body, such as using the add force method, which we're not going to do because we want to have precise control over our character's left and right and jump movement. So we're not going to use forces, but rather we're just going to be setting the velocity on the rigid body. But for gravity, we can have that handled with the gravity scale down here. So if I go ahead and hit play in dynamic mode, you'll see that our character already starts falling. So whatever our gravity settings are on the project are going to apply to this character and any other character in dynamic mode. One setting I do want to change though, down here under constraints, freeze rotation. We're never going to want our platformer character to have the sprite rotate around in circles. We just want to have that frozen in place. So that means that the transform on our player is not going to rotate, so you'll never see anything like this happen to our character, as long as the freeze rotation constraint is checked. So now we can shrink both of these. And before we get to creating the player controller script, let's save this game object as a prefab inside of our project. So click on the assets folder, right click in the project, create a new folder for characters. So I'm going to call it characters. Double click on it. I'm going to right click and create a new folder for the player. And while we're at it, I'll just create a enemies folder in advance as well. So a game project is going to have a lot of different files in the end, so it's just a good idea to try to keep things organized from the get-go, so it's not confusing later. So in the player folder, let's jump in there. To create a prefab, we simply need to drag the game object from our scene into the folder. So left click, hold, drag it down here, and you'll see a prefab object will be created down here. If you click on it, you can see the components, just like how we had dragged it from the scene. And you also see in the hierarchy that a game object linked to a prefab is blue. It also has an arrow on the right, which you can click on to edit the prefab. So how prefabs work is this is a game object saved in the project assets. So anywhere we need it in a scene, you could just drag it into the scene, left click, hold, drag. And each instance in our scene is going to be based off the basic settings inside of the prefab. So when I drag it into the scene, it is a copy of whatever's in our project folder, but you can change it from that point. So if you need to, let's say, triple the scale on X, make it a chunky boy here, you can do that. Now this doesn't actually update the prefab. If I click on the first one, you can see that the other player is still scale 1. And if we double click on the prefab in our project, then you can see this still has a scale of 1 by default. So you can have an object that's based on a prefab and then customize all of the settings as you need for the game. Maybe a character needs to have more or less HP than the basic prefab version of it. Okay, so I'm going to delete the extra player 1 from the scene. Now, once you've created a prefab, if you add another component inside of the scene itself, that component is not going to be automatically updated on the prefab. So at this point, if you want to add something to a game object that applies to every prefab instance, it's a good idea to work in the prefab itself. So you can click the arrow and open the prefab for editing. Now let's do add component, and I'm going to type in player controller, which Unity isn't going to recognize as an existing component, so we're going to use new script to create it. So just new script, player controller, create an add. So now if we click on the assets folder, we can see our C# script automatically created here. But I want to put all of our scripts into a scripts folder so that we know where they're all located. So I'm going to right click in the project, create a new folder. I'll call it scripts here, and I'll drag player controller into it. So now double clicking on scripts, we can, well, it needs to reload the script assembly, so give it a second. Now we can double click on the player controller, and it will open up in our code editor. So by default, that's Visual Studio. I'm using Visual Studio 2022 community version just for reference. And what you should see here is public class player controller, which is inheriting from mono behavior. So anything that's going to be a component you attach to a game object in Unity needs to be a mono behavior, which gives certain functionality to it, like the ability to call start and update methods. So these are part of the lifecycle for your Unity game. Every mono behavior technically has these methods and they run at different times. So start would be when the game object becomes active for the first time in your scene, and update will run on once per frame of the game. And this version of update can vary depending on how fast your computer is, but we can use this for anything that wants to be updated as fast as the game and the current system it's running on can process. So now that we have this script open, I'm going to jump back to Unity for a second because we need to add the player input component. So add component and type in player to find player input. So click on this. And because I'm not editing the prefab, you'll see a little plus next to the icon for it, which means that this is an added component that doesn't exist on the prefab. So if you want to add this to the prefab now, you can still do it by clicking on the 3 dots on the right and then do added component, apply it to prefab player. Then if you jump into the prefab, you should see it here as well. So if you forget to edit on the prefab, it's okay. You can still apply changes to the prefab from the instance if you need to. So every player input is going to need a input action asset. So the input actions are going to define which keys do what in our game. So to create one in our project, click on create actions. And I'm just going to call it player import actions.import actions. And I suppose we'll save it inside of characters and then players, and just save it in there. So when you create the import actions, you'll see action maps, player, and UI. So the UI is going to handle things like button clicks later on, and then player is going to be for moving the player game object. So you can see by default we have move. You can extend that and see the different key inputs that you can use to move the player. So WASD on the keyboard or left stick on a gamepad. To look around, you can see using the right stick to move. We won't be doing anything with this because we'll just have a follow camera always stuck to the player. And then fire, which would generally be used for things like firing a bullet or, in our case, a sword attack. So because we don't have any projectiles that we want to fire with at least the left mouse button yet, I'm actually just going to click on the name here and rename it to attack. So now this is no longer a fire action, but the attack action. So if we close out of this player input and hit save to update it, you might notice that in our list of functions that would be sent to the game object by default, on fire changed to on attack. So when you're in behavior send messages and you want to respond to one of these things happening on our player input, you would just implement a method with the same name in your game object. So if you create on attack, this will be called whenever the on attack left mouse button is pressed on our player input. But the thing about send messages is that it looks for all of these functions to be called on any of the components on this game object. If you do broadcast messages, then it would go to children game objects as well. So it's possible that a function would get called that you didn't intend to get called when a button's pressed. or you might not know exactly where it was being called. So instead of using send messages as our behavior, we're actually going to use invoke UnityEvents. So this will create a new dropdown down here. If we click on it, then you can see further dropdowns. So we're looking for player, and then player has this attack callback context. So attack is the event. Callback context is the parameter that's going to be passed to the function from our player controller script in order to handle the event. And then we can click on plus down here later to add the function in to be called when attack happens as an event. So when you do things this way, instead of just responding to a message by having the same function name, you have to directly set the function you want to call when these events happen. But that also means you can very clearly see exactly what's going to happen on each of these events triggering. So now let's jump back to our player controller script. We're going to need a function with no return type, so that's void. And I'm going to call it onAttack. For right now, though, the event that we're going to handle with this video is move. So you can see that this gives us the parameter callback context. So we have to make sure that our method has that as a parameter. So back in our player controller script, so down here at the bottom, I'm going to create a new method. So void is going to be the return type, and then I'll give the name of it onMove. But we have to get the callback context parameters. So what you're looking for here is input action dot callback context. And we can just call it context here. Okay, so now it has the parameter. And now we need to read a vector2 value from the context. So the way we know that the data that we're receiving is a vector2, the up, down, left movement, basically X and Y, is if we check the input actions, you can look at the action and see the control type. So this is giving us a value as a vector2. So we can get the movement input here, but rather than making it a local variable, I want to declare it at the top of the script. So I'm going to call it vector2, which is going to have an X and a Y value as floats, move input. And then down here on move, we'll set that each time on move is called. So move input equals context dot read value. And the type of value we're reading is a vector2. So you can see Visual Studio 2022 is automatically trying to complete that for me. So I'll just hit tab and have the line kind of write itself. Okay, so we have our vector2 value. So that's going to be the X movement input and the Y movement input. So whenever our move input is checked, I want to see if this value is not equal to vector2.0 to make sure that it's moving. And if it's moving, then I want to set is moving to true. Otherwise, I want to set is moving to false. So I'm going to do this as a property, which means I'm going to make the first letter capital. So is moving is equal to move input does not equal, so that's a exclamation mark equal, vector2.0. So this is going to give us a true false statement, and we can use that to set different values. Then we just got to end the line. So we're going to get an error because is moving does not exist in the context. So if we click over here, I can hit control period in order to generate a property automatically. So I'm going to generate that at the top, is moving, and we can just leave this as a automatic get and an automatic private set for now. So we'll come back to this later, but we'll be able to use this property in order to change other things, like whether we're playing the idle animation or the moving animation on our animator component later. Okay, so now the important bit is that move input is going to be set on every frame. So we want to take that and we want to multiply our movement input by the time between frames and then the move speed of our player in order to generate how fast it's going to be moving left and right. So let's create a public variable, which allows us to set it in the inspector to change it and customize it for our character. And we'll do float, so has a decimal point if we want it. And then we'll do walk speed. Later we'll have a run speed. So the walk speed we'll set to 5F for now. And then we'll use this speed, adjust it in order to control how fast our character walks. So when we want to do a physics update, which is anything to do with a rigid body generally, then we want to do that on void fixed update. So let's do void fixed update here, just like so. Okay, then we want to set the velocity on the rigid body to actually make our character move, but we haven't gotten reference to the rigid body component on the player controller. So if we look at our player game object, you can see the public walk speed variable showing here. That's good, but we still need this rigid body component. So how do we get another component on the game object, but then to use it inside of our script? So we can go to the top of our script and type in rigid body 2D, the type of component. I'll put RB to reference that this is a rigid body. And then we're going to add one more method, another lifecycle one, to our script. So void awake. So awake will happen when this component exists inside of our scene, but start only happens once it exists and is enabled. Start comes after awake and will only be ever called once. So if we want something to be found as soon as possible, we want to put it in awake. So RB, and then we can do equals get component rigid body 2D, just like it says here. I'm going to hit tab just to make that quick. So rigid body 2D is the type. We're getting the component, and this automatically assumes the game object that we're currently on, and it takes no parameters. So this means on awake, the rigid body is going to be set. It's going to reference that rigid body that exists on our player game object, if it exists. Otherwise, it will throw an error. If you want to make sure that anytime you add a player controller, that a rigid body exists, then what you could do is go up here to the top and do square brackets, require component, type of rigid body, 2D. So make sure that's actually set to 2D here, because that's going to match this one. And this will mean that you can't add a player controller to a game object unless a rigid body already exists. And if there is a player controller, then you can't remove the rigid body from the game object until the player controller has been removed. So it's not required, but if you want to be more certain that this component exists on the game object, then you can just put this little line at the top to do that. Okay, so now what we need to do on fixed update is do rigid body dot velocity, and we're going to set this equal not to move input directly, but to a new vector 2. So because we're controlling the walk movement of our player, we're going to set the walk velocity to move input.x. That's the x or horizontal input that we get from our player's input. We're going to multiply that by the walk speed for now. And then we need to make sure that our movement is consistent. So I'm going to do times time dot, and let's do fixed delta time. So minor correction here for the x movement on our velocity. When you set the velocity, it already factors in the per second speed and updates that on every frame. So we don't actually need to multiply this by time dot fixed delta time, because that bit is already being handled by the rigid body's internal movement itself. So just do move input.x times walk speed. If you see the movement being really slowly, it might be because you're still having the times time dot fixed delta time or times time dot delta time. So we can hit comma, and then we want to find out the y velocity. So right now, the y velocity is going to be completely controlled just by gravity. So we don't want to change that. We want to keep it the same as it was before. So do rb.velocity.y, and then end it. So the vector 2 takes two inputs. Here's our x, and here's our y. Okay, now we can jump back to the game view. Let's try hitting play, and you can see our character still falls. So for right now, I actually want to turn off the gravity so that we can see just our movement. So let's expand the rigid body component in the inspector, take the gravity scale, and set it to 0 temporarily. So if we hit play, try doing WASD, and you'll see we still don't have any movement. That's because we haven't linked up the onMove method to the Unity events for our player input. So now we can go down to player input, and let's expand the events, make sure that behavior is set to invoke Unity events, expand player, find our move callback context event, hit plus. We can drag the player controller script into here, or you can drag the game object from our scene hierarchy into the slot here. I'll just do the quicker way, player controller into the slot. Now click on no function, find our script name, player controller, and then you're going to want to do the onMove callback context, but we can see that that's not there right now. The reason for this is that the function is currently hidden because it's still private. So back in the C# script, go down to where it says void onMove and just put public in front of it and save the file. So now going back to the move event, click on no function, controller, and you want to choose onMove the dynamic callback context. So now that the Unity event has the method here to invoke, we should be able to see movement on our player when we hit play. So once again, for the walk speed, set to 5. Make sure it's not multiplying by times dot delta time in the fixed update. Let's hit play, and we should be able to see some solid movement for our player. If you want to change this temporarily to increase or decreasing it, and see if you like it better, you can change the number. So walk speed set to 3 while we're still in play mode, and you can see that it immediately changes our speed. You can try 7 if you want a character that walks faster. When you exit out of play mode, it's going to revert back to the default value you had set before you hit play. So anything you change in play mode is just for testing, but shouldn't actually change your project permanently. And if I was to re-enable gravity scale to 1 right now, I hit play and I move left and right, it's going to fall, but also still being able to walk left and right. So if you set up the velocity set correctly, it shouldn't be interfering with the up-down movement due to gravity. The left-right should just work on its own.